we've done multiplying, we've done dividing, we've done powers to a positive integer. This is how you find the roots of a complex number, okay? For a positive integer p, the complex number r cis theta has p distinct p-th roots, okay? So I hate to say that you've been lied to your whole mathematical career, but basically you've been lied to your whole mathematical career, okay? So you've been told that the cubed root of 1 is 1, and that's it. There's only one of them. But there's actually 3. We have always said powers, if you have a 5th degree polynomial, okay, that it's going to have 5 solutions. If you have a 7th degree polynomial, it's going to have 7 solutions. Same concept. Complex numbers include real and imaginary. So 3, 2, 1, those are complex numbers. If I'm looking for a root, okay, a positive integer root, so the second root, third root, fourth root, fifth root of a number, doesn't matter what kind of a number it is, doesn't matter if it's real or imaginary, because that encompasses all complex numbers, it will have just as many solutions, okay? So if I'm looking for the 5th roots of 1, I will have 5 answers. If I'm looking for the 5th roots of 2 plus I will have 5 answers, okay? Some of these answers get messy. A lot of them do not have nice numbers. They do not have nice radicals or fractions or things like that. They pretty much, it's decimals, okay? So how do you find them? Here's my complex number, r cis theta, okay? To find a, again, positive root of a number, this starts off the same. So I take my modulus to 1 over p, okay, whatever that power is. This is where it gets a little goofy because I have to have p answers, okay? If p is 6, I have to have 6 answers. If p is 2, I have to have 2 answers. So this is the way they write it in the book. They write it as 1 fraction, okay? I'm separating this into 2 fractions for you so you can see because you're just adding something every single time, okay? So the first one, and I'm going to cover this up, is just like using DeMoivre's theorem. I take my modulus to the 1 over p power, and then I take theta times 1 over p, or it ends up being theta divided by p, okay? So whether it's a power or root, your initial 1 is exactly the same, okay? What you are doing is you are going to add these fractions until you get to 1 less than p. You can actually accidentally keep going, but then you will get the same answer that you got to begin with, okay? Because these are going to be cyclical. So if I'm finding the 5th root, I would take r to the 1/5. I would take theta divided by 5. This theta divided by 5 is going to stay the same. I would add 2 pi over 5. Then I'd add 4 pi over 5. Then I'd add 6 pi over 5. Then I'd add 8 pi over 5. And then that'd be it. Those would be my 5 answers, okay? So p-th roots of unity means finding the p-th roots of 1, okay? So you've always been told the square root of 1 is 1. Well, there's actually 2 square roots of 1. There's a real and there's a complex, okay? Cube roots of 1, 4th roots of 1. If they ask you to find the p-th roots of unity or the nth roots of unity, you can use whatever variable you want here. Your book uses a p, okay? So you're going to use that for these problems. All right, so I have lots of space for these. 4th root of -4 minus 4i. All right, and I'm also going to kind of show you a visual as we do this. So -4 minus 4i. -4 minus 4i puts us right here, okay? My fourth roots of negative 4 minus 4i, I'm going to have 4 arguments. Those 4 arguments are going to be here, 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 and here. They are going to be at equal increments around my plane, okay? So I take, this is going to be, and I'm not even going to simplify it because I'm going to end up plugging these all in my calculator, and they're all going to be messy, okay? So a squared plus b squared equals c squared. I realize that this is 4 squared, it's a 2. You can write that, but that's going to be more parentheses in my calculator. So I'm going to leave it as the square root of 32. So I have the square root of 32. My first answer, you need your argument here. Well, this is pi fourths, so it is 5 pi fourths, okay? And I have to take 5 pi fourths times 1/4, and I have to take the square root of 32 to the 1/4 power. So this was equivalent to the square root of 32 cis 5 pi fourths. So my first root, I take this to the 1/4 power, and I take this times 1/4. You don't have to simplify this at all. You can leave this, but this would be equivalent to 32 to the 1/8. So I'm going to write that because that's less writing for me. And then this would be equivalent to 5 pi 16ths. So there's my first answer. I am finding the fourth roots, so I'm going to have 4 answers. So this is the same for all of them. To find what I add, excuse me, I take two pi times 1 over 4. Oh, and this was a 16. I take 2 pi times 2 over 4. And I take 2 pi times 3 over, so that is not agreeing with me right now, over 4. These, if I have 2 pi times 4 over 4, 4 over 4 is 1, I'm going to get the same answer that I got here, okay? Because I would have done 1 complete cycle. I'd be right back where I started from, okay? Let me show you a faster way to plug these in the calculator, okay? So I'm going to do 32 to the 1/8 power. I have the old style, so I have to have that in parentheses. Now, the calculator does not have a cis abbreviation, okay, unfortunately. So I have to do cosine of 5 pi 16ths plus I is right here, I sine of 5 pi 16ths. Oops. So my lovely answer, my first one, is 0.86 plus I times 1.28, or let's do 1.28i, since that's how we usually write it. There's my first one, okay? Now I'm gonna go second enter in my calculator, and I'm gonna come back up here, right here, and I'm gonna go second insert plus. I'm gonna write out, and I'm not gonna put this, I'm just gonna put 2 pi. So I'm gonna do 2 pi divided by 4. And then down here, I'm gonna do second insert, and I'm gonna do 2 pi divided by 4. Oops, plus 2 pi divided by 4. So my second answer is gonna be a negative 1.28 plus, it's a really bad plus sign, 0.86i. Notice those very similar numbers. I'm going to go second enter again. This is now equivalent to 4 pi, so I'm going to come back up here and just change this to a 4 pi and change this one to a 4 pi. So my third answer is a negative 0.86 minus 1.28i. And then one more. I'm going to change this to a 6 pi. And this to a 6 pi. And I have 1.28 minus 0.86i. And if I accidentally kept on going, okay, I had 0 pi, 2 pi, 4 pi, 6 pi, and if I change this to an 8 pi, watch what happens. 0.86 plus 1.28i. I get right back where I started from, okay? All right, one more. Cube roots of unity. The cube roots of unity mean all the cube roots of 1, which there are 3 of them, okay? So if I want the cube roots of 1, I'm going to have 3 answers. Well, I have to write 1 in complex form. Well, it's not very exciting, but it's 1 cis 0. Okay? So if I want all the cube roots, I'm going to take 1 to the 1/3 power cis 0 divided by 3. So yeah, it's just 1. Okay? My second one is going to be 1 to the 1/3 power cis 0 over 3, which again is just 0, plus I'm taking 2 pi times 1 over 3. And then 1 to the 1/3, which again is just 1. And then I have 0 over 3 plus 2 pi times 2 over 3. Cube roots of unity, 1, 2, 3 answers. Cube root of 1 is 1. You already know one of your answers. You've had that problem numerous times in your lifetime. This is all going to be 1. I don't even have to write it out. But I'm going to do the cosine of, this is 0, so I don't have to write that out. Cosine of 2 pi thirds. Now, if I'm doing this on the calculator, I'm going to get a decimal approximation. On this particular problem, they could ask you for the exact answers, okay? I believe in your homework that some of them ask for decimal approximations and some of them do not. But cosine of 2 pi thirds, you have to be able to recognize that this is not a calculator problem, especially if they're looking for an exact answer. So this is going to be the cosine of 2 pi thirds plus I sine of 2 pi thirds. All right, 2 pi thirds. If you need to draw yourself a picture, draw yourself a picture. So 2 pi thirds, this is going to be 60 degrees in here. So this is going to be a negative 1, 2, and the square root of 3. So the cosine of 2 pi thirds is a negative 1/2. And then the sine of 2 pi thirds is square root of 3 over 2. So this is one where we can get an exact answer. And they are going to ask you for these. This one again, 1 to the 1/3, 1. 0 divided by 3, 0. So this is going to be 4 pi thirds. So I'm going to have the cosine of 4 pi thirds plus I sine of 4 pi thirds. Again, if you need to draw yourself a picture, draw yourself a picture. 4 pi thirds would put you down here. This is going to be pi thirds or 60 degrees down here. So this is going to be -1, 2, and negative square root of 3. So the cosine of 4 pi thirds is a -1/2. And the sine of 4 pi thirds is going to be a negative square root of 3 over 2. So I'm actually going to change that to a minus. So if I took this to the third power, I should get 1. So I can check my answers, because if we're finding the roots, it's just like the square root of 4 is 2. If I take 2 squared, I get 4. The square root of 25 is 5. If I take 5 squared, I get 25. So if I take a -1/2, half, plus I square roots of 3 divided by 2, and I take that to the third power, I get 1. So those are all your cube roots of unity. Those are all your cube roots of 1. You now know the rest of the story.